Good morning, students. यश, कालच्या लेक्चरला का नव्हता तू? यश कोकाटे. ओके. स्क्रीन दिसतेय का?
हो.
ठीक आहे. बरीच मुलं काल अब्सेंट होती परवा. त्यांना मला एक गोष्ट सांगायची आहे. शनिवारी पण आपण एक एक्स्ट्रा लेक्चर घेतलं होतं, त्याच्यामध्ये सॉलिड स्टेट संपवून टाकलं. आणि काल रविवारी आपण 2 एक्स्ट्रा लेक्चर घेतली, त्याच्यामध्ये आपण थर्मोडायनामिक्सला सुरुवात केली होती. See, this thermodynamics is one of the biggest chapter in the physical chemistry actually. Means the numericals and some of the physics is included in this thermodynamics. So this is actually quite boring than the organic chemistry for the teaching also, and for the learning also. This chemical thermodynamics is quite boring because no any reaction mechanism and uses and properties is not there. All the theoretical part is included in this chemical thermodynamics. So I will help you to make it interesting, because the weightage, you can see the weightage is 8 marks weightage. It is the largest weightage in physical chemistry. So whatever the important part, I will tell you on which the question can be asked for the board exam. So yesterday we started the introduction part is completed. What is mean by this system and surroundings? Once again, I will do the quick revision. See, this system and surroundings means a portion of the universe which is taken for the thermodynamic study. It is called a system. In this example, we can see gas is a system, and this is surroundings. Yes. So in this diagram, clearly we can see a gas which is fitted with this piston. This is a piston. The gas is fitted in the cylinder. So the gas is the system, and the other material, it is surrounding. Means this cylinder is also surrounding. The room is also surrounding. So a system plus surrounding is equal to universe. Remember. In this diagram also, it is clearly we can see this circle. It is a system which is a part of the universe which is taken for the thermodynamic study or observation. There is a boundary which separates system and surroundings. It is called as boundary. And other this rectangle, it is a universe. So universe is made up of with system plus surroundings. Then the types of systems. Yesterday we discussed about this types of system depending upon the exchange of matter and energy. In case of open system, both matter and energy is exchanged. In closed system, matter cannot be exchanged, but energy can be exchanged with the surroundings. And isolated system means thermos flask, in which both matter will be not exchanged, and also the energy will be not exchanged with the surroundings. So this is important for the board examination. They can ask for 1 mark, what is open system, closed system, and isolated system. And then extensive and intensive properties, very, very, very important for the board examination. The examiner can ask the question on it, which of the following is intensive property, or write one examples or two examples of intensive property, extensive property. So detailed, I have explained yesterday. Extensive property means this property depends upon the amount of matter. If the amount of matter is changed, these properties will be changed. See, but intensive property, it is independent on the amount of matter. Means if the matter is changed, these properties will not change. See, the pressure will not change, temperature will not change, melting point, boiling point. Also, I have given yesterday one example. If you taken the 100 ml water and if you take 2000 ml water or 2 liters water, the melting point and boiling point remain same. So these properties are independent on the amount of matter, and this extensive property depends upon the matter. Matter is changed, then properties will be changed. So remember this property. Then also I explain about the state function. What is meant by state functions? State functions which depends upon the state of the system. If the state of the system change, also the properties will be changed. See, this is the initial state, and this is the final state. In the initial state, the pressure is P1, volume is V1, temperature is T1. And in the final state, see, it is clearly we can see the pressure is changed. It becomes P2, volume is V2, and temperature is T2, but number of moles remains same. So the number of moles is not a state function, but pressure, volume, temperature, internal energy, enthalpy, these are the state function which depend upon the state of the system. And there are another functions which are called as path functions, which depend upon the path of the system. There are two path functions, work and heat. Then also we discuss about this isothermal process. The temperature is constant. Adiabatic means there is no exchange of heat between system and surroundings. Isobaric means pressure constant. Choric means volume constant. And reversible process is very important. Generally, in case of every stage of the system, driving force is infinitesimally greater than the opposing force. So driving force means when the system expands, there is a driving force from lower to upward. This is called as driving force. And opposing force means top to bottom. It is external atmospheric pressure. It is called as opposing force. So generally, driving force is infinitesimally. Infinitesimally means this is a very, very, very small amount of change. It is called as infinitesimally greater than the opposing force. This is in a normal processes are conducted by this way, in which the driving force is infinitesimally greater than the opposing force. If this forces are changed, means if the opposing force is infinitesimally greater than the driving force, the system will be reversed. Means instead of expansion, compression will take place. So always remember, in case of reversible process, opposing force is infinitesimally greater than the driving force. So I have also made a correction in my notes. Also in the brackets I have given, if the external pressure of the piston, external pressure means it is opposing force. So opposing force is greater than the driving force, the system is reversed. And these features also, we discuss about these features yesterday. These features are not asked for the examination, but these processes are very important. Isobaric process, isochoric process, then reversible process. So this is a, actually we discuss in detail, but many students are absent yesterday. For these students, just it is a quick revision. Then also I explained this is the nature of heat and work. In case of mechanics or Other than thermodynamics, work done means what? It is force into displacement. If a force is applied on any object, the displacement will take place, and that force into displacement, it is called as work done. But in case of thermodynamics, this work done is different. It is a pressure volume work. It is a pressure volume work, means if the pressure is changed or volume is changed, work will be done. So this pressure volume work is done when the system expands or contracts. Because system in this thermodynamic system is taken as a gas. When the gas will expand or gas will contract, the work will be done. So what will happen during expansion and during compression? We will see during the expansion, volume increases, so work is done by the system. Remember, these two different conditions are there. When the gas will expand, its volume will increase. It's when the volume will be increased, work will be done by the system on the surroundings. And opposite to this contraction, when the contraction is takes place, the volume will be decreases. Volume will be decreases, and work will be done by the surroundings on the system. See here, work is done by the surroundings on the system. So these are the two conditions are very important during expansion. What is happening? Work is done by the system on the surroundings, and during contraction, work is done by the surroundings on the system. It is opposite. Actually, this thermodynamic work and mechanical work is same. This is explained here in detail. So in case of thermodynamics, the work is pressure volume work. The P is actually the force per unit area. So we are going to put this value in this equation. So P is equal to here force upon area into V, but area is again distance square, and volume will be the distance cube. So the d square root will be cancelled, and finally work is equal to force into displacement. So the mechanical work and the thermodynamic work is the same actually. So these are the two examples given when the system expands and the system will contract. See, these examples are not for the examination point of view, but for the understanding, it is given what is happening when the system will expand. Actually, see, this is a reaction of decomposition of H2O2. The system will expand. Why the system will be expand? See the reaction carefully. Twice H2O2 liquid, it decomposes to give twice H2O plus O2. This O2 gas is liberated. See here, H2O2, it is kept in this cylinder. This cylinder is fitted with this piston, and the weight is kept on the piston. Uh, why the weight is kept? Because when the gas will expand, what will happen? This piston will move upwards, and if you want to decrease the external pressure, we have to remove these weights. So for that purpose, these weights are kept on this piston. So if the reaction takes place, what will happen? The O2 gas will be generated, and this O2 gas will push the piston upwards. So what will happen in this condition when the gas will expands? Work is done by the system on the surroundings. See, it is written here, work is done by the system on the surrounding. Opposite to that, there is also one example of compression reaction between NH3 and HCl gas. In this case, there is a contraction takes place. See NH3 and HCl, what will happen? See the before reaction, see the volume, and after reaction, see the volume here. The system here, contraction takes place. So during the contraction, work is done by the surroundings on the system. Remember, so these are the two examples for your understanding purpose. No any question will be asked on it. Then next part is sign conventions. This is important for 2 marks, because for the board examination they can ask, if the value of q is positive, then what will happen? If the value of q is negative, then what will happen? if the value of W is positive and the W is negative. So this is the diagram you have to remember. In this system it is shown at the center. First I will discuss this W. Work is done by the system on the surroundings, remember. Work is done by the system on the surroundings. Just it is misplaced to this side, but actually it should be here. So minus W, remember, first minus W means when the system expands, the work always it will be negative, remember. When the gas will expand, the work is done by the system on the surroundings and W is negative. So if you remember this, W is negative, and automatically we will write when the W is positive. When the W is positive, here work will be done by the surroundings on the system, remember. Here if the W is minus, work is done by the system यहाँ पे work कर रहा है surroundings के ऊपर. But if the W is positive, the W is positive in case of contraction. When the gas will contract, means work is done by the surroundings on the system here. Work done here on the system by the surroundings means surrounding work कर रहा है system के ऊपर. So first we have to remember this W, minus W and plus W. Then I am coming to the minus Q. Minus Q means heat is released here, and plus Q means heat is absorbed here. So this is a very important sign conventions. When the W is positive, W is negative, Q is positive, Q is negative. Q negative means heat is released by the system to the surroundings, and here heat is absorbed by the system from the surroundings. Then again the 2 marks question will be asked on this topic, expression for pressure volume work. It is called as PV work. Derive the relation between pressure volume work. Such type of question it is asked for the board examination. So if this is actually very easy, I will tell you at the last how to remember the relation. This diagram, you have to draw the diagram. Consider a certain amount of gas with constant pressure P. It is included in the cylinder. So this is a cylinder which is in this cylinder. Gas is uh, in the cylinder. The gas is there, which is having the constant pressure P here. And this is a cylinder which is fitted with this piston. This piston we can move upwards and downwards. This is frictionless. No any friction takes place with the. See, this is the area of the piston. See, we can see clearly this is the area of the piston. Initially, the piston will be here. Initially, the volume will be V1. If the gas expands, what will happen? This gas will push the piston upwards, so the volume will be changed. So, initially, the volume of the gas is V1. After expansion, what will happen? The volume will be changed. It becomes V2. So, on expansion, what will happen? Force exerted by the gas is equal to area of the piston multiplied by pressure. See here what will happen. On expansion, what will happen? This piston is moving upwards. This piston will moving upwards against the external atmospheric pressure. That is opposing force is there from top to bottom. That is from top to bottom, and this is driving force. Driving force is from uh, what you can see from bottom to top, that is below to upwards. See this arrow, this is the driving force upward direction, and opposing force it is from top to bottom, that is downward direction. So there are two forces are there, one is driving force and one is opposing force. So on expansion, force exerted by the gas is equal to the area of the piston. See, this is the area of the piston pressure, multiplied by pressure, with which the gas pushes against the piston. This pressure is equal in magnitude but opposite in sign. So we have to write down directly here. Force is equal to P external into A. P external minus sign is there because the gas expands against the external pressure. See, there is opposing force, so the gas is expanding against the external pressure. That's why the minus sign is given here. Pressure into area. So force is equal to pressure into area, where P external is a atmospheric pressure. If the piston moves out distance d, see it is a distance d, initial position is here, and after expansion what will happen? The volume will be changed, the distance is d initially. So after expansion, it will move to the distance d. So if the pistons moves out distance d, then amount of work done. Now you can calculate the amount of work done. W is equal to force into displacement. Here we can write W is equal to force into displacement, but we have to put the value of force. Force is here P external into area. So we are going to put the value P external into area, P external into see, yes, P external into area. We are going to put this value of force into this equation. So it will be P external into area into D. D as it is kept. But the product of A into D, this area into distance, see the product of area into distance is volume. That is the change in volume, that is V1 to V2. So directly we can write this A into D, it will be delta V. Delta V, it is a change in volume. The product of area and distance is change in volume. Change in volume, it is denoted with delta V. So again, we are going to put the value of delta V in this equation. So this 4.3 equation will be minus P external into delta V here. Delta V is nothing but the product of area into distance. And delta V means it is the volume change V2 minus V1. So this is expression, it will be as for 2 marks. W is equal to minus P external into delta V, or we can put the value of delta V, V2 minus V1. So this equation 4.5, it is as for the 2 marks. Derive this equation. There are two conditions where V2 is the final volume of the gas. When the gas will be expand, what will happen when the gas will be expand? Work is done by the system on the surroundings. When the gas will expand, V2 is greater than V1, so W is negative. Opposite to this, when the gas will be compressed, what will happen? Work will be done by the surroundings on the system. See here, work is done on the system by the surroundings. Or we can write work is done by the surroundings on the system. Here V1 is greater than V2, W is positive. So these two conditions are very important when the system is expanding and when system is contracting. When the system expands, always W is negative. When the system contracts, W is positive. The work, here work will be done by the system and here work will be done by the surrounding. Now these are the tips I have given to remember for the board exam. For the board exam only we have to remember these steps. Work is equal to force into displacement, F into D. But in case of thermodynamics, this force is minus P external into area. So this P external into, yes, P external into area, it is given. So we are going to put these values in this equation. So W is equal to P external into A into D, but A into D, it is a change in volume, delta V. So it is a very easy derivation, but some students feels it is not difficult to understand, it is very easy. Remember these steps, then we will get 2 out of 2 marks. So this is a very important question, like intensive property, extensive property. Many times this derivation is asked for the examination. Derive the pressure volume work. So we have to write this derivation. W is equal to P external minus P external into delta V. This is also required for solving the numericals. Remember this work done, uh, thermodynamic work done. This is pressure volume work. Free expansion. Free expansion means if there is no any opposing force, the expansion will be continue. So free expansion, it is the process in which opposing force is zero. Means if the opposing force will be zero, what will happen? The gas will expand continuously. If there is a no any opposing force, what will happen? It is called as free expansion. Free expansion means it is against the zero opposing force, because if there is no any opposing force, what will happen? The gas will expand continuously. Such expansion, it is occurs in vacuum. So when the gas expands in vacuum, there is no any opposing force. Remember, this condition is possible only in case of vacuum, because in case of vacuum there is no any atmospheric pressure. In generally, if you carry out the reaction on the normal surfaces, always external pressure will be there. That is, opposing force is there. So free expansion will not take place generally in general conditions. So for the pre-expansion, we have to conduct the experiment of the expansion in the vacuum. In the vacuum, there is no external pressure. Atmospheric pressure is not there, so the expansion will be free. So P external will be zero, so the expression will be, if the external pressure is zero, it will be zero into delta V, so the work will be zero. Means in simple words we can write down, if there is a free expansion, there is a no work done. Remember, तिथं काम होणार नाहीये, कार्य होणार नाही, कारण for the work done, opposing force and driving force should be there. If the opposing force is not there, work will be not done. If the Once again I am repeating this reversible process. When the system will be reversed, when the opposing force is infinitesimally greater, म्हणजे वरचा एक्सटर्नल प्रेशरचा फोर्स जर जास्त झाला, तर एक्सपान्शनच्या ऐवजी कॉन्ट्रॅक्शन सुरुवात होईल. लक्षात घ्या तिथं. मीन्स opposing force is a very very small amount, it is greater than the driving force, the system will be reversed. Remember, instead of expansion, contraction will take place. So for the work done, opposing force should be there, but there should be a small difference between the two forces, driving force and opposing force. Driving force is in upward direction and opposing force is downward direction. Remember these conditions, so no work will be done in case of free expansion. These are the units of energy and work. These are given, these are useful for us for solving the numericals. 1 joule, 1 joule is equal to 1 kilogram meter square per second square. This is a unit of joule. 1 joule is equal to 1 kilogram meter square per second square is equal to 1 Pascal into meter cube. These are the conversions required for solving the numericals. Joule to Pascal, then Pascal, 1 Pascal is equal to 1 kilogram per meter per second square. So I request all the students, please write these units on one paper and paste this paper in front of you in your study room. This is very important for solving the numericals. Joule and Pascal. 1 Pascal is equal to 1 kilogram per meter per second square. Now I am coming to the bar. These all are the 1 bar is equal to 10 raised to 5 pascals. Remember. So already we know about the pascals. 1 bar is equal to 10 raised to minus 5, sorry, 10 raised to 5 pascals. We are putting these values. 10 raised to 5 kilogram per meter per second square. So this is a bar and Pascal relation. Now I am coming to the dm cube bar. 1 dm cube bar is equal to C. It is written here. 100 joules. Directly, I am coming to the final step. 1 dm cube bar is equal to 100 joules. Remember this one. And 1 joule is equal to 1 joule is equal to 1 dm cube bar divided by 100. So these conversions we will see later, because these conversions we are using in the numericals also. See, we will take one numerical which is as for the examination. For this is a numerical for 2 marks numerical, and this is a 3 marks numerical. 3 moles of an ideal gas expanded isothermally. Isothermally. Now you must know what is mean by isothermal process, because in the types of processes I explain what is mean by isothermal process. See, I will show again isothermal process, adiabatic process. So this isothermal process means here temperature of the system remains constant. It is called as isothermal process. So here 3 moles of an ideal gas expanded isothermally from 15 dm cube to 20 dm cube uh, at constant external pressure of 1.2 bar. The pressure is given, the volume is given. Initially, the volume is 15 dm cube. It is the final volume means V1 and V2 is given. V1 is 15 dm cube, V2 is 20 dm cube. The pressure is given. Calculate the amount of work done. Means we have to calculate the work done in dm cube, bar and joule. Means in 2 units we have to calculate the work done. So we already know the formula. W is equal to minus P external into delta V. Delta V is nothing but V2 minus V1. We having the values of pressure is 1.2 bar, volume V1 is 15, because all the values are given. Only we have to substitute the values in this equation. Minus 1.2, put the values of V2 20, put the values of V1 15 here, 1.2 into 5 dm cube. So it is a simple multiplication, minus 6 dm cube bar. So in dm cube bar, the answer is calculated. W is equal to minus 6 dm cube bar. Now we have to convert into joule. We have to convert into joule. We already know this formula. Conversion is there. 1 dm cube bar is equal to 100 joule. This is from these units. 1 dm cube bar is equal to 100 joule. So this is required for the conversion of dm cube into joule. So we have to multiply by 100. So W is equal to minus 600 joule. So this is a 2 marks numerical. Means we are going to put the values only. So you must know the formula. This is a formula, and we have to put the values here. Only this conversion is very important. dm cube bar and joule conversion. Again, one example, it is given in your textbook also. This is solved example. Calculate the constant external pressure. We have to calculate here. P external, we have to calculate here. P external required to compress 2 moles of an ideal gas from volume 25 dm cube to 13 dm cube, when the work obtained is, means value of W is given, work done is given, value of W is given here, V1 is given, V2 is given. So V1 is 25 dm cube, V2 is 30 dm cube, W is given. The same formula we are using, W is equal to minus P external into delta V, or minus P external into V2 minus V1. So just we are going to put these values. Just we are going to put the values of W here, substituting these values in this just we have to do this conversion. See, W, it is given in joules here, 4864.4 joules. W is given, it is in joules. We have to convert into dm cube bar. So this relation, again we have to use this relation. 1 dm cube bar is equal to 100 joule, and 1 joule is equal to 1 joule is equal to dm cube bar divided by 100. See, 100 joule. It is this conversion is done. Joule, it is converted into dm cube bar. So if we have to convert this joule into dm cube bar, we have to divide it by 100 here. So 48.62 dm cube bar. It is converted joule to dm cube bar. So again, we are going to put these values. Work W value is 48.62 dm cube bar. Then P external is given here or not. We have to calculate P external. Yes. So P external as it is kept. Then V2 is 13 dm cube. V1 is 25 dm cube. So P external minus 12 dm cube. So by rearranging this equation, P external, it is kept as it is. So this 12 dm cube we have to divide it to this side, left hand side. So P external is equal to 48.62 dm cube bar divided by 12 dm cube. This dm cube will be cancelled, and we will get this answer 4.052 bar. This is a external pressure. P external, it is calculated in bars. So these are the very simple numericals. Such type of numericals will be asked for the examination. Just remember this formula: W is equal to minus P external into delta V, and delta V is nothing but V2 minus V1. So again, some examples are given in your textbook also. Tomorrow we will start this concept of maximum work, when the maximum work will be done. So just I will give the introduction of the when the maximum work, म्हणजे जास्तीत जास्त वर्क कधी होईल त्याच्या काही कंडिशन्स आहेत. तर आपल्याला आता समजलंय की तिथे सिस्टम मध्ये देर आर टू टाइप्स ऑफ फोर्सेस. वन इज अपोजिंग फोर्स, वन इज ड्रायव्हिंग फोर्स. अपोजिंग फोर्स जर जास्त झाला तर सिस्टम रिव्हर्सिबल होते, आणि अपोजिंग फोर्स जर कमी असेल तर रिव्हर्सिबल रिॲक्शन होत नाही, लक्षात ठेवा. तर हे अपोजिंग फोर्स जर तिथं अपोजिंग फोर्सच नसेल, इफ देर इज नो एनी अपोजिंग फोर्स, नो वर्क इज इन्वॉल्ड, फ्री एक्सपान्शन होईल तिथे. फ्री एक्सपान्शन आपल्याला नकोय. एक्सपान्शनला कंट्रोल करायला अपोजिंग फोर्स पाहिजे. अपोजिंग फोर्स जर असेल तरच वर्क डन होईल, लक्षात घ्या. हे थर्मोडायनामिक्स सगळ्यात महत्वाचं गोष्ट आहे की जर अपोजिंग फोर्स नसेल तर वर्क डन होणार नाही. अपोजिंग फोर्स तिथे पाहिजे. So with increasing opposing force from zero, more work will be needed by the system. When the opposing force reaches the maximum, the system performs maximum work. हे लक्षात ठेवा. When the opposing force reaches the maximum, system performs the maximum work. मॅक्सिमम वर्क होण्यासाठी अपोजिंग फोर्स मॅक्सिमम पाहिजे. जर अपोजिंग फोर्स जास्त झाला, लक्षात घ्या, अपोजिंग फोर्स जर जास्त झाला तर सिस्टम रिव्हर्सिबल होईल, आणि आपल्याला तेच पाहिजे. म्हणजे मॅक्सिमम वर्क होण्यासाठी अपोजिंग फोर्स थोडासा जास्त पाहिजे, लक्षात घ्या, ड्रायव्हिंग फोर्स पेक्षा. म्हणजे मॅक्सिमम वर्क हे रिव्हर्सिबल प्रोसेस मध्येच होतं, कारण रिव्हर्सिबल प्रोसेस मध्येच अपोजिंग फोर्स थोडासा जास्त असतो. किती जास्त असतो? इन्फिनाइट सिमली, लक्षात ठेवा. व्हॉट इज मीन बाय इन्फिनाइट सिमली? मीन्स व्हेरी व्हेरी स्मॉल अमाऊंट. सो opposing force maximum, if the opposing force is maximum, work done will be maximum. And ही कंडिशन कधी येणार आहे? when the system will be reversible. कारण रिव्हर्सिबल प्रोसेस मध्येच अपोजिंग फोर्स थोडंसं जास्त असतं ड्रायव्हिंग फोर्स पेक्षा. ह्या सगळ्या गोष्टी इथं याच्यामध्ये दिलेल्या आहेत. अपोजिंग फोर्स बिकम्स ग्रेटर दॅन द ड्रायव्हिंग फोर्स, द प्रोसेस गेट्स रिव्हर्स. सो the work will be maximum when delta P is smallest. What is this delta P? Since the opposing force cannot be greater than the driving force, it should be maximum. So this delta P is the difference between P and P external. It is if the pressure P of the gas differs from